Okay. So, looking at this question, recording down so that you remember what I said. All right. Now you have, if you see a dotted line with a R, a small R inside the box, you have what they call internal resistance. So the battery is no longer ideal. So it's not an ideal cell. All right, so these are a few things you need to take note, which means that whatever circuit you are analyzing, you have to include the R. You have to include the R in your analysis. That is why we have something called terminal potential difference. So this is a standard straightforward question that you are supposed to know. Okay. All right. Because of this R, so due to internal resistance, some work is done to drive a unit charge across it. Therefore, there is a drop in potential difference. Okay. So your 2.5 that you are given here comes from the cell. But are you getting 2.5 here? No, it'll be more or less. It'll be less than 2.5. Okay. So you have to find out what's happening. All right. For the first one, this one is very straightforward. Whatever that you have, battery, current through the cell, 0.1 ampere, EMF of the cell, you should use that 2.5, P equals to IV, 2.5 is your V, your I is 0.1, that will give you 0.25 watts. Okay? Resistance of the load. So we use what information is given about the load, 0.2 watts. This is power once again. So we can use P equals to IV. We can, but since we are finding resistance and you're given I, so you can use I squared R to go and find. So 0.23 watts equals to I squared R. What is your R that you get in the end? 23 ohms. Okay, once again, check for your SF. 2SF is given, so your answers should be in 2SF. Internal resistance R of the cell. Okay, so now that you have this, you can find the internal resistance. If you are given 0.23 watts and you are given the ampere, the current, P equals to IV, like I mentioned, you can use it. You can find the potential difference across the load, which is 0.23 divided by 0.1, that is 2.3 volt. Okay, so this is 2.3. If this is 2.3, this should be, if this is 2.3 volt, this should be 2.5 minus 2.3, that'd be 0.2. Okay, if this is 0.2, so let's go down to create an answer. potential difference across the small r. Okay, so express your working properly equals to you have to find potential difference across the big R, which we found out to be 2.3 volt, is based on 0.23 watts divided by 0.1. So you can express your working properly. This should be reversed lah, okay, which is over here. Then your small r, put it in the next line, equals to 2.5 minus 2.3, that'll be 0.2 volts. Your internal resistance R is therefore 0.2 divided by 0.1. That'll be 2 ohms. Okay. Another way that you can find, alternatively, okay, you are given a total EMF of 2.5. V equals to IR. Total EMF is 2.5. Total current is 0.1. So you bring out a bracket. The other R is 23 plus the small r. So if you solve for R, you should get 2 ohms as a result. So you can do this. Solution number 1, solution number 2. Whichever way is fine. So for the next one, we have to explain quantitatively whether the load is ohmic. So the first thing you want to ask yourself is, what is an ohmic device? An ohmic device obeys. And what is Ohm's law? Potential difference proportional to I. Or V directly proportional to I. Okay? In a sense, R is constant. So again, basic concepts that you have to pin it down. Okay, this question is a bit tricky because they neglected to include the internal resistance. So this question is tricky. So to help you to visualize, you need to draw this in. So when I say they neglected, doesn't mean that they forgot. They intentionally neglected. Okay? So your R is constant, which is because the batteries are the same, so your R is, you can consider R as 2 ohms. Your small r equals to 2 ohms. So put that in. Okay, consider that. Now you have 2 batteries combined. So it's 2.5 plus 2.5 equal to 5 volts. Okay, so because you are asked to explain quantitatively, you are given numbers here. You are supposed to somehow express your working or your answers with working. So first, you need to find out your total current. So you need to assume that device is ohmic. All right. Then the total current will be. Now, because the device is ohmic, the R is constant. So you take the 5 volt, the total potential difference or the EMF, divided by the total resistance. 2 plus 2 plus 2, 2 plus 2 plus 23. And how much is that? 0.185. Or 0.19. So you express this and then you compare. Are they the same? Okay. The current should have been 0.19 ampere if it is ohmic. But the current is the current is 0.15 ampere. Therefore, device is non-ohmic. That's all. Any question? Okay, few things to take note. You should get 1 mark for displaying your understanding of Ohm's law. R is a constant, so you got to put this in. 1 mark for showing your working. The last mark is comparing your values. So this is where the 3 marks allocations are. So you got to take note of that. Okay.